Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another computer science lecture for 9618A2. This is chapter number 18, Artificial Intelligence. Now let's see. Now this chapter also technically has just one subsection, 18.1, Artificial Intelligence. As you know very well from your AS and from your O levels, artificial intelligence is the ability of a computer to simulate human-like intelligence, to do tasks that only a human would be able to do, such as decision making, such as speech recognition, such as speech synthesis, etc. The field of AI have had many remarkable evolutions, and among the various techniques, graphing or graphs are a standout as a critical tool. They are essential for representing complex relationships and problem-solving scenarios in AI. Now, what exactly is the structure of a graph? A structure technically has two things. One is known as node or a vertex. What are vertices? Vertices are these, like the point of contacts, whereas edges or links connect two or nodes together. Now they also show the relationship or the transition between them, or they also tell you what will be the cost of traveling from node A to node B. Over here it is 4. The nature of these connections can vary significantly from simple association to complex relational dynamics. However, rest assured, for your P3 you will not be having much complex design of graph to deal with. Now usually we have two types of graphs. We have a directed graph where arrowheads are used in order to show the direction. Now this basically means you can go from A to B, but you cannot come from B to A. Or we have undirected graphs, which is represented in form of straight lines. That means you can either go from A to B or B to A. Without the straight line is usually without an arrowhead. Graphs are now let's discuss why and how graphs are needed in AI. Graphs are needed in order to model complex relationships and networks. They represent various states and scenarios in decision making and problem solving. They are a visual way of simplifying the understanding of complex systems and datasets. They are used for problem solving. They are often used to model problems where various states and their connection needs to be analyzed, such as in route planning or decision trees. They are used for knowledge representation, showing how different concepts are interconnected, something like a brainstorming diagram. Now, when you are using graphs in your AI, the topic of AI, then there are many algorithms which are used to traverse graphs in order to find link between two different nodes. Now navigating through graphs is a very key aspect. There are multiple algorithms, but for our A2 syllabus for P3 we have two algorithms in our syllabus. One is known as the A** algorithm and the other one is known as Dijkstra's algorithm. First of all, let's discuss the A** search algorithm. It is designed to find the most efficient path in a weighted graph. Now graphs can be weighted or unweighted. Weighted means every node will have some value and every path will have a price, whereas in unweighted graph will not have those. It combines the feature of uniform cost search and pure heuristic search to efficiently compute paths. These are uniform cost search and heuristic search are a type of searches. Like I said, there are many types of searching algorithms. However, in our syllabus we only have two methods, so you can basically cut this part out if you don't want to fill your head with it. A** use a heuristic function to estimate the cost of cheapest path from a node to the goal, or from the starting node to the goal. The estimation helps in prioritizing which path to explore. Generally, A** is more efficient than Dijkstra due to its heuristic nature. How to implement the A** algorithm? Well, first of all, mark all nodes as unvisited. You'll be given a algorithm. You'll be given a graph like this. You'll be told what is the starting node and what is your destination node, and then you'll need to you'll be also be given a table like this, and you'll need to calculate that what is the best path from the starting node to the ending path. So ending node, sorry. Now secondly, mark the picked starting node with a current distance of 0 and the rest nodes with estimated value needed to reach destination. Now what this basically means, here our starting node is S. Now how many nodes does S connects with? It connects with an A, it connects with a B, and it connects with a C. Alright, if you go to A, you'll have to use 4, or the cost for going to A will be 4. For B it will be 10. If it's easier for you, you can consider this as the distance as well, although we usually prefer to use the term cost. For C it will be 11. So what we will do, we will solve it like this. I've already solved it. So S, cost from home, is 0 because S is your home or your starting destination. The heuristic for that is S. The heuristic means whatever is written as the price of that node. Like standing at S, you're utilizing 7 units. The total is calculated as always, cost from home plus heuristic. Then from S you can go to A. The cost for that will be 4 and the heuristic will be 8. So the total cost of going from S to A will be 12. For B it will be 10 plus 6, 16, and for C it will be 11 plus 5, 16. So as you can see, you will solve it like this. S will be 0, heuristic was 7, total will be 7. Then we have A, cost from home was 10, heuristic was 4. Sorry, it was 4 and 8. Sorry, 4, it was 8, it's 12. I'm just solving it as an example so you know how to solve this table. I'm basically resolving it. I've already solved it. Now, so for A, now we have to look at the total. You can ignore the S, that is your starting node. You cannot ignore it. There's no way for skipping it. It has to remain there. So just ignore it for now. And out of the nodes that connect with S, A, B, and C, or if there are 4 or 2, you have to check which one has the lowest total cost. Out of A, B, and C, the lowest total is of A for 12. So that means from S will move to A. Where is that? From S will move to A. Now we'll consider A as our home and we'll see how many nodes does A connect to. So it connects with B and it connects with D. So we'll calculate a total for both of them and record it in our table like this. For B, A, B, C. After that we will add B and D. Now when you remember this, cost from home means you have to calculate from the beginning. So from S you'll have to come to A. So 4 for that, then 8 for heuristic, and then 8 for reaching B. Okay. So 4 and 8. For reaching B from S, you'll be needing 4 of this and 8 of this. And then the heuristic for this will be 6. So 4 plus 8, 12 will be the cost from home and 6 will be the heuristic. We'll record it in our table. 18 will be the total. Then for D, again we follow the same path. From S to A it will be 4, and from A till D it will be 5. So 4 plus 5 is 9. That will be the cost from home and 5 will be the heuristic. So 9 plus 4, 14 will be the total cost. Out of these two, 14 is the least, so we'll take that. So basically we'll go from S to A, and then from A we'll go to D. Now we'll move to D and repeat. As you can see, D connects with H, D connects with I, and D connects with F. So let's calculate the cost from home. Like I've already done that, so by now you would have grasped the concept. So let me just directly show you the solve table. Now for H it will be 4 plus 5 plus 16, as you can see. Four, 5, and then 16. Then for I it will be 4, 5, and 20. For F it will be 4, 5, and 1. This will be cost from home. Heuristic is for H it is 7, for I 4, and for F 3. Out of these three, HI and F has the lowest total of 13. So basically it means from S will go to A, from A will go to D, and from D will go to F. Now from F we can directly go to G. That's our end goal. F is directly connected with G. Plus there are no more branches, so we'll just directly go over there. For that it will be 4 plus 5 plus 1 plus 13. That will be the cost from home. 0 is the heuristic. So as you can see, there we go. Now for the final path, usually at the end of the table you have to mention the final path as well. So how you'll write for your final path, just write all of the nodes that you have picked so far in sequence, like from S, arrow A, arrow D, arrow F, arrow G. See, for G it's coming out to be 36 total, like this, and this will be your answer. You'll easily score something like 4 or 5 marks for this type of question. It is a rare question, but it does come in the paper. Next we have the Dijkstra's algorithm. This algorithm is known for finding the shortest paths between nodes in a graph, especially in graphs with non-negative edge weights. Dijkstra's algorithm calculates the shortest path from a starting node to all other nodes in the graph. It doesn't just calculate the path from one node to a specific node. It does so to the all other possible nodes. Now it does this by systematically exploring the most promising paths first. Although it is effective, it can be less efficient in larger graphs, as it would need to calculate a lot of paths in order to find the shortest one. Now how would you solve a question related to Dijkstra's algorithm? First of all, the very first step is to mark all nodes as unvisited. Now you'll get a graph like this, and then you'll basically get a short table. Let me show you something like, let me copy paste it. So you'll be given a blank table like this. In fact, Cambridge is obviously not going to give you such a colorful table. Let me make it blank. Yeah, this is more like it. As you can see, if you start at 0, you'll have 8 possible nodes to go to: 1, 2, 3, 4, 5, 6, 7, and 8. In this graph, we don't have the concept of heuristic. You'll just have to look at and tell that from if you start at 0, or whatever is your starting node mentioned in the question, what will be the cost to travel to each of the following nodes. So what you are going to do, mark the picked starting node with a current distance of 0 and rest nodes with infinity. Okay, you can ignore this. Now fix the starting node as the current node. For the current node, analyze all of its unvisited neighbors and measure their distance by adding the current distance of current node to the weight of the edge that connects the neighboring node and current node. So basically, if you're going from 0 to 1, what is the cost that you have to pay? That is 4, right? From So you'll just record it over here that from 0 to 1 it will cost you 4. Next, if you are going to 2, then you'll need to travel minimum distance from 0 to 2. That will be, first you'll go to 1 and then from 1 you'll go to 2. There is no other way. There can be another way, like you can go from 0 to 7, then 1 and then 2, but that will be 8 plus 11 plus 8, that will be too much. Now you can also go from 0 to 7, then from 7 to 8 and then 2, but also that will be too much. This is the minimum that you'll be needing, that will be 12. Similarly, the minimum distance from 0 to 3 would be 0 plus 1 plus 2 will be 19. The path will be 0, 1, 2 and 3. 0 to 1, 1 to 2 and 2 to 3. You can try other combinations as well, but over here only record the shortest path. The minimum distance from 0 to 4 will be 21. How? It will be 0 to 7, 7 to 6, 6 to 5 and 6 to 4. You will need to record this path somewhere as well. The minimum distance from 0 to 5 will be 11. So you'll write 11 over here and you'll record this path somewhere, that okay, from 0 to 7, then you go from 7 to 6 and then you go from 6 to 5. That will be the shortest path. From 0 to 6 it will be 9. You can go from 0 to 7 and then 7 to 6. Then from 0 to 7 it will be 8. You go to 0 to 7 will be 8. They are directly connected. From 0 to 8 it will be 14. It will be, first you'll go from 0 to 1, then 1 to 2 and then 8. Here 0 to 1, 1 to 2 and 2 to 8. You'll complete your journey. Now this will be the output. Basically we'll need to write it in form of a table, and if you have another node of 0, obviously the distance for that will be 0. So like this you'll need to fill up your table, and that's it. Once you have filled this table, that's it. You'll get yourself something like 5 marks for solving this table correctly, like this. Now, how do we utilize this algorithms? A** algorithm is ideal for situations where an approximate distance to the goal is known. It is used in various applications such as in video games, pathfinding, etc. Whereas Dijkstra's algorithm is best suited for applications involving unweighted graphs, where you don't know the heuristic for each node, so the graph is unweighted, or when the shortest path to all the nodes are required, such as when being used in network routing protocols. As when you're planning network routes, you need that short distance or the shortest possible distance to all the available routers in the network. Here is a more concise comparison between them. Dijkstra is uninformed search algorithm. A** is informed search algorithm. Dijkstra finds the shortest path from source to every other node. A** finds the shortest path from source to a single destination only. Dijkstra considers actual cost only, whereas A** consider the actual cost plus heuristic cost, which is more like an intelligent estimate. Dijkstra algorithm uses basically in Dijkstra the cost of each node is calculated by f of n is equals to g of n, whereas for A** it is supposed to be the total cost is supposed to be the traveling cost plus heuristic. Alright. Next we have the artificial neural networks. ANNs are the forefront of evolution in machine learning. These are used by machine learning systems in order to learn new things, in order to utilize the past data, and in order to mimic human cognitive functions. Now, how they are used in machine learning, they have dramatically transformed machine learning by offering sophisticated means of handling vast and complex data. They are very important in enabling machines to perform tasks that require human-like intelligence, such as pattern recognition, decision making, and predictions or analysis. This is what artificial neural network looks like. There is an input layer where data or query is inputted. Then we have multiple hidden layers. This diagram only shows two. Well, in reality there can be several hidden layers, and then we have the output layer where a conclusion is established. The hidden layers are where data from the input layer is processed into something which can be sent to the user, basically the output layer. Hidden layers are used when the complexity of the problem requires more than one layers to solve it. They enable a neural network to learn and make decisions on their own and improve the accuracy. They excel in recognizing patterns in data, a fundamental aspect of learning and decision making. Their ability to analyze historical data or past data and predict future outcomes is very valuable, like in fields like weather forecasting, stock market analysis, financial analysis, disease outbreak prediction, and something like geological surveys, etc. Basic structure of an ANN artificial neural network: they are designed to mimic the thinking process of human brain. Hence, they are consistent of multiple interconnected nodes, which kind of resemble the billions of neurons, special cells inside the human brain. Now, the components, as you know, we have an input layer which receives raw input data. Each neuron or each node in the input layer represents a feature of input dataset. Then we have multiple hidden layers. They are the actual processing. This is where the actual processing happens through a system of weighted connections. Now, this is where Dijkstra and A-star algorithms, there are many more as well. This is where such type of algorithms kind of come into play. Then we have the output layer, where the final output derived from processing the data through multiple hidden layers is given back to the user. Neurons or nodes are the building blocks for this. They are interconnected through pathways, each associated with a weight determining the strength and the direction of influence one node has on the other. The weight of each connection is adjusted during the learning process to improve the network's performance. Now, how does this artificial network works? It functions through a series of steps that involve feeding the data into the network, processing it through layers, and adjusting the weight of different nodes in order to improve the output accuracy. The learning process. Input data is fed into the network where each feature corresponds to a neuron in the input layer. As data passes through each layer, neurons process it by summing the weighted inputs and passing the sum through an activation function. These functions determine whether a neuron should be fired based on the weighted sum of its input. Now, how do you train an ANN? Data moves through the network from the input to the output layer. Each neuron's output becomes the input for the next layer. The difference between the network's prediction and the actual output is calculated, and this is known as the percentage error, or basically this is the error calculation. Finally, backpropagation is used to adjust the weights in reverse from output back to the input layer to minimize prediction errors on the next run. Simulating the learning process. The ANN simulate human learning process by adjusting their responses based on the feedback received. They improve their performance by learning from data They adjust their own weight to reduce the error between the prediction and actual outcome. A well-trained ANN can generalize from its training and perform accurately on unseen data. These, yeah, I know this is kind of like boorish read through, but that's something I believe you should know about. Like you won't probably be asked direct questions about all of this, but it's better to read through it rather than skip it completely. So if there's some very difficult out of the blue question, you would be able to answer it up. Applications for artificial neural network in machine learning. Well, there are several applications in medical diagnosis. ANN can process patient data to assist in accurate diagnosis. They can, well, there was a famous case, you can search it up on the internet as well. AI detected cancer in a patient's x-ray something like 4 or 5 years before it actually developed in far enough for the doctors to detect it. They are also used for credit scoring and risk assessment based on historical financial data. They are used in voice recognition systems and translation services, which is commonly known as natural language processing. Challenges in implementing an ANN. While they are very advantageous, while they are very beneficial, there are a handful of limitations or disadvantages as well. The training process, especially for deep neural networks, can be very much restraining on your computer. Like there has to be a lot of processing involved. The performance is highly dependent on the quality and quantity of the training data. If the training data is not of optimum quality, the network you'll make will not perform well as well. If a artificial neural network is too complex, it may perform exceptionally well on training data, but it might fail to live up to its expectation when it encounters newer data. Now, last but not the least, we have the concept of machine learning in our syllabus. So let's go through it and see what it means. Machine learning is a subset of AI where systems or machines are developed, softwares are written in such a way that they can perform tasks, even those tasks for which they were not programmed, that were not hardwired, that were not programmed in their code. They can use past data to modify their own code, and they can perform new tasks all on their own without a programmer sitting at the back end improving their code. It's a very common example for that would be ChatGPT. You can give it a chemical equation and it will balance it for you. You can give it a mathematical equation and it will solve it for you, explaining to you all the necessary steps and the final answer as well. Now obviously there is no mathematician sitting at the back end who trained or who coded ChatGPT to solve different types of mathematical equations. The ChatGPT learned it all on its own. That's the best thing about machine learning. Now some key concepts that you should know about machine learning, or rather how many types of learning is there. So we have supervised learning and we have unsupervised learning. Supervised learning means training the algorithm on a predefined set of data, which includes the input and the desired output. The algorithm gets a label as an answer for its prediction. So basically you give the input data to the algorithm and you tell them, okay, you should get the answer as this. Then the algorithm tries different ways in order to get the desired output. Once it does, it is given a label. Then we have unsupervised learning. In contrast to it, it involves training the algorithm on data without any labels. There is no final output. The system is not told the right answer. The system has to figure it out using its own logic. Reinforcement learning. This is much different compared to the aforementioned two types. It is about taking suitable actions to maximize reward in a particular situation. Basically, this is used by various software and machines to find the best possible path or behavior it should take in a specific situation. This is basically where you provide additional data sets for something your machine, your software has already learned in order to re-strengthen its performance. Then we have the semi-supervised learning, where we use both labeled and unlabeled data. Typically a small amount of labeled data with a very large amount of unlabeled data, so the algorithm can have the best of the both worlds. Another concept of ML involves deep learning. It is where computers learn to solve problems using neural networks similar to how the human brain functions. For example, image classification. For example, plants phenotyping. It consists of neural networks. It uses a vast array of neural network, and each layer of nodes is trained on a distinct set of features based on the output of the previous layer. Then we have feature extraction. One of the biggest advantage of deep learning is its ability to perform automatic feature extraction, or you can say automatic pattern recognition, which makes it much better. Deep learning versus machine learning. Deep learning requires large amounts of data to be effective, whereas ML can work on small data sets as well. Deep learning requires high-end machines, whereas ML can learn on low-end machines as well. Testing of an ML based system takes a long time, whereas testing of deep learning system takes much less time. Deep learning reduces task of developing new features extractor for each problem, because they can automatically extract or recognize patterns, whereas ML needs sometimes or frequently needs a feature extraction or pattern recognition methods. So basically AI is making of machines that think and behave like humans. Machine learning is the second layer where system learns without being programmed to learn, and deep learning is basically making a software or a machine that is very much close to the cognitive abilities of a human being, or the thinking process that goes around in a human brain. Application of these. Again, this is some additional data that I think might come in handy in one of the questions. So yeah, just bear with me. Healthcare. Machine learning algorithms are used for disease identification, diagnosis, drug discovery, medical imaging, etc. In finance, they are used for fraud detection, risk management, customer service, and algorithmic trading. For retail, they can assist in inventory management, personalized shopping, supply chain, customer services, etc. For transportation, optimized shipping routes, optimized traffic routes, predicting vehicle maintenance, and enhancing logistics. Reinforcement learning, learning through interaction. Reinforcement learning is learning what to do and how to map situations to actions. It is different from other types of learning in that correct input or output pairs are never presented. Principles of reinforcement learning. The agent is the learner or the decision maker, and the environment includes everything that it interacts with. The agent's actions result in a reward, which can be positive or negative. The goal of the agent, the learner, is to maximize the total reward. An agent must exploit what it has already learned in order to obtain a reward, but it must also explore in order to make better decisions in future. It can be used in gaming, where it is used to develop computer programs that as the more a user plays against them, the much better they become, such as chess, such as Go. In robotics, it is employed for robotics in path planning, in control, and other tasks. In self-driving cars, it is used to make decisions like when to speed up, when to slow down, when to change lanes, etc. Impact and advancement in AI. Human-like performance. In some deep learning models, there have been absolutely human-like performance in image and voice recognition. From self-driving cars to personalized medicine, these technologies are reshaping industries. They are making AI applications are making services more accessible and more efficient, from customer service chatbots to automated financial advisors. Now, what are the challenges or drawbacks of all of this? Computational cost is very high. Okay, data quality and availability, as we have learned, an ML or a deep learning data set can only work as good as the data set you provide them for training. Ethical consideration: as AI becomes more prevalent, issues like data privacy, job displacement, and algorithmic biasness comes to forefront. Machine learning categories. Machine learning can be categorized into two fundamental types: supervised learning and unsupervised learning. These categories form the foundation of how machine learning models are constructed and applied in real world scenarios. What are they? We have already discussed, but since they were mentioned in the syllabus with ML, so I kind of have written them again. This is the same thing, supervised learning with a labeled data set, and it involves training the model on data set where the outcome of each input is known. You can have direct feedback. The model receives immediate feedback during training process, enabling it to learn and adjust its prediction. Prediction focus, primarily used for predictive analytics, it includes classification and regression tasks. Now, what are the application of supervised learning? Something like email filtering, like spam filters, medical diagnosis, real estate pricing, weather forecasting, etc. Disadvantages: overfitting, the risk of model becoming too tailored to the training data, leading to poor performance with actual data. Quality and availability of labels. The training performance is heavily based on the availability and accuracy of labeled data, which might take a lot of your computer resources. Then we have unsupervised learning, discovering hidden patterns. Core features: it does not have any labels. The computer has to come up with patterns on its own or recognize patterns automatically. The algorithm has to organize and interpret the data autonomously on its own, forming clusters or reducing dimensions. Now, where do we use unsupervised learning? For customer segmentation, in marketing or in market research, in genomic sequences, where you have a vast amount of genetic data and you are sequencing it genetically. Big data visualization, simplifying large data sets to 2 or 3 dimensions for visual analysis. For noise reduction, filtering out noise from data to in voice calls, etc., in order to enhance the performance. The challenges or the disadvantages: outcomes from unsupervised learning can be ambiguous, and there can be trouble in interpreting such outcomes. Measuring the effectiveness or accuracy of unsupervised learning model is very challenging, as you don't have a right answer to give to the computer. So basically it can give you multiple wrong answers, or it can give you any answer, because there is no right answer. Now, how do you compare both of them together? A clear supervised learning demands a substantial amount of labeled data, which can be a limiting factor, whereas unsupervised learning can work with unlabeled data. Unsupervised learning is often perceived as more complex because obviously you don't know the correct answer. However, it offers more flexibility in exploring and understanding data. While supervised learning is predominantly used for predictive modeling, unsupervised learning is made tailored towards data exploration and discovering underlying patterns. For example, somebody finds a scroll written in something like a 4,000-year-old language. Now nobody knows that language anymore, and you provide it to AI, you scan it, upload it to an AI, and ask them to translate the scroll for you. Now, since there is no dictionary available for that language, the AI will have to use unsupervised learning model in order to try and decipher the code. Backpropagation of errors in neural networks. Backpropagation is a cornerstone in neural networks. It refers to a method employed for refining the weight of a neural network. Now it contains of a neuron that you already know about. It contains of weight. Weights are the parameters within neural networks that transform input data according to the network's architecture and the activation function. An activation function determines whether a neuron should be activated or not. Process. One thing we have is a forward pass. Input is passed through the network, generating an output. Loss calculation. The difference between the predicted output and actual output is called loss calculation. Backward pass. If the error is propagated back through the network, allowing the algorithm to adjust weights optimally. Now, how does this help us or the system in learning? Its aim is to reduce the error rate by adjusting network weights, leading to more accurate predictions the more you use the system. The process iteratively refines the model, improving the performance with each epoch, like one complete pass or one complete processing of a dataset. Regression method in AI. It is primarily used for prediction and forecasting based on the relationship between the interdependent variable and the dependent variable. Types and functions. We have linear regression. It models a linear relationship between the dependent and independent variable used for continuous outcome predictions. We have logistic regression, best suited for binary classification problems such as predicting probabilities, the likelihood of an error occurring. Applications in AI for regression. Market trend analysis used in financial reports to predict stock prices, for weather forecasting to predict the temperature, rain, UV, shade, etc., other weather conditions for a certain area, and last but not the least, used for healthcare predictions in predicting patients' outcomes or disease progression. And well, that's everything you need to know for chapter number 18. I know the last few slides might feel like not really related to the syllabus, but they'll come in handy in the larger picture. So I'll see you guys in the next class. We'll inshallah start chapter number 19. Let me know whether you like this lecture or not. Give me a thumbs up if you do, and share it with your friends. Take care. Allah Hafiz.